Hey everyone, welcome to the another lecture. And today we are discussing about linear regression. That what it is, how do we use it, and what is its use in machine learning. Okay, so let's get started. Okay, so if we are learning about linear regression, then you must know that it is actually a regression problem. Okay, in the machine learning, we often get this that there are actually you know uh, three types of machine learning in which supervised, unsupervised, and reinforcement. Okay, and in the supervised, we have two kinds of problem. Okay, the first one is classification, or it could be regression. Okay, it doesn't matter. And the second one is regression. Okay, it could be used interchangeably. Here we can have regression and classification, but doesn't matter. The problem number doesn't matter. But actually here is the first is classification and second one is regression. Okay, so linear regression is a kind of a regression algorithm to solve the problem. Okay, that we know this now. So let's get started with ours. Something that we actually, what does it want to say? So if we look, then itself it wants to tell us that it is actually linear and it is a regression. So what is linear? Straight. We know that if anything is linear, it is straight. Okay. And what does regression means? Regression is nothing but it is a statistical method to solve a problem. Okay, it is a statistical method to solve a problem. Now, what does a problem statement wants to tell us that we are seeing? Okay, so in machine learning, we haven't given a problem, and we have to find that what problem does it is that if any algorithm is used, any appropriate algorithm that should be used to solve that problem. Okay, and we found that it is a regression problem, and it is also a linear regression problem. Okay, it is actually a linear regression problem. So in this thing, we have something is kind of a relation. Okay, a relation. Before that, let's get started off with an example. Okay, with an example. Okay, so suppose that you're working in a company. You're working in a company, and you completed first year. Okay, in the company. Then you completed 5 years in the company. Then you completed 10 years in the company. What a specific thing that will always be permanent, or which cannot be changed actually, that it will increase with your time. Think it is nothing but it's simple. It is nothing but your salary. It will increase. Why? Your time is increasing in the company. Okay, your experience is increasing in the company, and hence your salary will automatically increase in your company. Okay, it won't be same, but it will increase. Okay, it will increase. Now we have a relation. We have a relation actually between the years you spent. Okay, relation between and relation between what to use, not approximate, but yeah, we have a relation between years you spent with the salary you are getting. Salary you are getting. Okay, we found a relation that your salary is increasing as your year increases, or the time or experience increases. So what we found that if a person has around spent 20 years, then his salary would be much more. Yeah, will be much more. If he has, like spent 15 years, 10 years, 5 years, then his salary would be something, okay, lower than the guy who has spent 20 years. Now, if we see it geometrically, okay, graphically, then we would see that it is actually showing a linear, relationship between the year you spent and the salary you are getting. Okay, the salary you are getting. So we can keep this in our mind that this is the year spent and this is the time. Sorry, this is the salary. Wait. This is the salary and this is the year spent. Okay. Then salary would be something, in the $1,000, 500, 5,000, $500,000, something would be, per year. Now, so we could see a relation between the year you spent and salary. Okay. So we have something called as linear relationship between our two things. Okay. Two things. Now, the company, okay, the company tells uh, the this person who manages the finance or some person of finance team that we want a solution. Okay, we want a solution in which we want whatever time a person has spent his time. Okay, whatever time a person spends his time. Okay, whatever time it should be, his salary must be defined. His salary must be defined that if you are at this year, your salary would be this. And we know that as the year increases, my salary is also increasing. So we could get into an idea, or we could reach to a formula that can helps us to directly find the salary at whatever year. Okay, at any year. Okay, so we need to find the solution for it. What kind of solution we can have? What kinds of solution we can have? Okay, first thing that in the graph you could see that at which year you could find, but it will be more tedious. Okay, it will be more tedious to do. And the second thing what we can do is that we can make a solution. We can make a solution between our these two things, these two parameters, in which if we give the year we get the salary. Okay, if we give the year we get the salary. Okay, now it could be interchangeably used. I have it could be same, but the salary should be here and time should be here, but it doesn't matter, like it is a graph, so it can be, it's just an example. Okay, so what we can do, we can find a solution. Now how we can find a solution? We know that there's a relationship between the salary and the time. So if we work on the time and the salary, then we can definitely find to this we can definitely reach to a solution where it can give us our the our wanted solution, or our actual result of the problem that we want to get. Okay, so we used our brain, our genius brain, and we reached to a conclusion that we need something known as formula that we often use in mathematics, to predict something or whatever. We need a formula in which if we put something, okay, it gives us the y. If we put x, it gives us the y. Okay, if we put something, it gives us the y. Okay, now, so what we reached here is that, let's suppose, let's do a quick example. Okay, a quick example in which if a person have spent 1 year in a company, he will get $2,000 per month. Okay, $2,000 per month, or we could say 24,000, $24,000 per year. Okay, per year. This is per year. If he spent how much years? 2 years. Then he would get 3,000. Okay, 3,000 nothing but 36,000 per year. Okay, 3 on and on, and would be more 3,000, which is nothing but 4,000. which is nothing but 48,000 per year. Okay, and on and on and on and on and on. Okay, now we found a relationship between them is that there is a relation that it is increasing in a linear way. It is not actually going exponentially that, yeah, at fifth year you got that much of salary. No, not like that. What happened actually is that at a particular year, we got some particular more dollar into our bank after some amount of time. Okay, so we draw a graph. We drew a graph, something like this. Okay, something like this. Wait, let me. Why the hell? But yeah, this should be straight also. Yeah, we draw a graph, and we've said that this is suppose that the time that we are spending 1, okay, 3, 5, 8, 10. Okay, this is the time that we spent, and okay, this is the time we spent, and that is the salary what we got, the salary we got, which is something, dollar. Okay, now if we make a linear graph, if we make a linear graph and we see that what is the result at a point. Okay, let me set it to that. What is the point if we say to this point we have some particular salary. If we see this year we have some particular salary. If we see at third year we have some particular salary. If we see at the fourth year we have some particular salary. Okay, so we're seeing that there is a relationship. I'm using it again and again, but you have to understand it. There is a relationship between these. So can at any year, like suppose at the 59th year, we would have the same relationship and the same salary, system or same salary pattern at the 59th year. Yes, yes. And for that, we have to reach to a conclusion, and we have to find something that is not, actually that much of problematic to find. That is not too much of sorry, that is not too much problematic to, find at that time. Sorry for my vocabulary. I also make mistakes. So yeah. So yeah. So what we got is that we got a formula which y equal to mx plus b. This is the formula that we're using to find the salary of whatever year what we want at whatever year we want. Okay, so now how did we get this formula? We have to find this. How did we get this? How the hell did we find this? Okay, how the hell did we find this? Because this, it is not about only, the salary and the time patterns, about the other things also. There are a lot of things that are into linear and we have to find them. Then how did we reach to this particular formula to find this? Okay, so what we did actually, okay, what we did actually here is, this is what we call is nothing but uh, what we say. This is, the intercept. This is not. This is the solution we want to find. This is the slope. This is the intercept. Okay, and this is the input. This is the input, and this is the output that we want. How the hell did we got this? Okay, what are we finding? Y. If you give the x, it will give us the y. Now how did we got this? We have to find this. Okay, once you understand this, how did we find it? It will be very easy for you. So what we did, we used little bit of concept of calculus. Okay, what we used is calculus. Okay, and we found this. So we know that in calculus, this is if we zoom in. Okay, in calculus, what we do actually we zoom in and we see that rise over run. Okay, how much did we rise when we ran this much of distance? Okay, feel me. How much distance we rise when we ran this much of distance? Okay, so for the sake of example, forget those numbers right now. Can we say that this is our this point? Can we take this x1? Yeah, obviously we can take it. If we want to, we can take it x1. Can we take this point as x2? Yeah, why not? Because we don't know the numbers. Can we take this point, y1? Yes, definitely. Why not? Can we take this point y2? Yes, why not? Now, what is this distance? What is this distance if I ask you? It is nothing but x2 minus x1. Nothing but x2 minus x1. What is this distance? Y2 minus y1. Okay, this is nothing but y2 minus y1. And this is rise. How much did we rise? And this is run. Okay, how much distance did we run to reach there? Okay, now we know one thing is that rise over run. Okay, which is here is y2 minus y1. Okay, x2 minus x1. The distance, all the distances. Okay, now what we found that if we want to find the next point, that what will be the next point? Okay, if we have the x, the time. Okay, what is our y here? The salary. And what is the x here? The time that we have spent in the company. Okay, so this is the our desired output. Okay, this is actually the next point and this is the previous point. This is the previous and this is the next. Same to this is the previous and this is the next. Okay, now if we put this and this, we could find this. Okay, so suppose in this graph, which point is this? 0, 1, 2, 3. This is nothing but 3. Okay, this is nothing but 3, which is x1. Okay, which is x1, it is 3. And what is x2? Da 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 da, it's 1, 2, 0, 1, 2, 3, 4. What is nothing but 4. Okay, and suppose this will be in 2. Okay, 4, 6 in this term. This is 2, this is 4, this is 6. Then this will be 8, 6 and 8. Okay, if then it is 8 and this is 6. Okay, let's get the ratio. Let's get how much did we rise. Okay, so we went 2, 1. What we got? 2. And if we perform this here also, then we will get 2 also, here also, then we will get 2 also, because it will be same, it is linear. So we'll definitely get 2. We will definitely get 2. Now if you're getting 2, then always we'll get 2. Now suppose that we know these points. Okay, now another we have y3 minus y2, x3 minus x2. Okay, what is this? Is the point, this is x3 y3. Now we want to get this. Okay, now we know that it is 2, it will come to, we know that. What is y3? We don't know. What is y2? 8. What is x3? What is x3? We don't know. What is x2? 4. Got it? Got this? Now the simple maths. We can do this. We can do this. 2x3 minus 8. Okay, y3 2x3, it will be got minus and suppose we add 0 to it. Now what we have what we have here is that we have a formula that y doesn't matter. We have a formula that y into 2x plus 0. What is x? The input. What is 0? The intercept. And what is y? Our output. Our output. So we got a formula that if we give x to this and multiply it to 2, then we will get our desired output, which is in the term of this graph. Okay, this which is in the term of this graph. Now if we do same for another example, same for another, okay, then we would definitely get that. So this is how we got the formula of y equal to mx plus b. Y equal to mx plus b. Okay, this is how we got the formula of y equal to mx plus b for whatever, this is how. Okay, so the b is the intercept and m is the slope, and what the slope is nothing but slope is the rise over run is the slope. Okay, slope is nothing but rise over run. And what is rise over run? Y. Okay, if I don't generalize it, if I want to generalize it, then y minus y, suppose it is I, then it is I plus 1. Okay, are you getting it what I'm trying to say? Like suppose this is y, suppose that this is y hat and this is y. Okay, then x hat minus x. This is the previous one, these are all the previous one, this is the just next one. Okay, so we will get our slope, and for every, for the every x and x plus the next one, we'll get the same slope. So we could generalize a formula, and even we made like this, and that's how we got this formula. We reached to this formula that this will be used to predict whatever we want, the linear relationship. That's how we got the linear relationship. Okay, I'm taking so much time, but you need to understand that how we got this. Okay, I hope uh, you would have cleared this thing, that how we got this. Nothing, we did nothing, just okay, we did rise over run. The slope we got, and what the slope we got and we did is y slope into x hat minus x. Okay, we put x and y of the previous one to know the next one. Okay, for every previous one, because we want to know the next one also, no? Next one also. What will be this point, this point, this point, this point, this point? Because we don't know. Okay, we know it is a linear, but we don't know actual value of it. Okay, so we want to generalize it, and we have to sum it up in a formula where we actually can get at what we are doing. So we put this. Suppose that we put y. Suppose that we put 3. Okay, and the slope we got. Suppose we got 4. Okay, and the x, leave it, and suppose the x was 2. Okay, now y hat 3 equal to 4x hat minus 8. So y hat, we will just uh, take this to the right hand side, minus 8 plus 3. So y hat is nothing but 4x hat minus 5. And this is how we generalized the formula. This is how we created a formula for a linear graph. I know you have studied, but we have to get this, that how did we got this. So the video is getting longer, so I want to stop here right now, and we'll be continue to the next lectures. And I hope you would have got clear with the idea that how did we got our this formula. And next time I will, keep it very short, concise, and in a very short way to make understand. So definitely I will make some new lectures. So thanks for watching till right now. If you have any doubt, ask me in the comments, and Discord link given in the description below. Link given. I don't know how to talk speak this but the link is given below in the description. And if you have any doubt, please ask me out in the comment and the Discord. So thanks for watching right till now. Bye bye.